On a Linux system, the operating system kernel controls all hardware and software resources. The shell exposes kernel functionality so that the user can administer the system. The shell can be a GUI program, a graphical user interface program, like the X Window system that is running here, or it can be a CLI program, a command line interface program. But in the Linux world and the wider Unix world, when we talk about the shell, we talk about the command line interface. The default shell on Linux is Bash. When running a graphical shell, we can still get access to a command line shell via a so-called terminal emulator, like the one that is running in this window here. Let's write a first Bash program. The program consists of a single simple command. The command word is echo, and there are two parameters. The first one being hello, and the second one world. When we press enter, the terminal emulator sends the command line to the shell. The shell sees that it has to execute echo. The echo command receives the parameters and just sends them, separated by a space, back to the terminal emulator. Hence the name echo. Maybe not the name that we would choose for this command, now that the terminal emulator is typically co-located with the shell on the same machine. But the name dates back to a time when the command would have been keyed in to a teletype terminal and sent over a cable to a big expensive computer for processing. And the result would then be sent back over the cable to the terminal that would then teletype the result on paper or display it on a screen. The terminal emulator emulates the behavior of such a TTY or teletype terminal. Because of the speed with which the echo command is handled, it might be hard to notice, but if we just provide the command line with a simple command, we cannot issue a new command until the shell has finished processing the command and a new prompt is printed, prompting us to provide another command. Here, the shell didn't do a lot of processing. It just went to sleep for 5 seconds. A simple command can be a bit more complicated than just a command word with optional parameters. A series of variable assignments and redirections can precede it, and at the end, a further series of redirections may follow. To illustrate, and really just to illustrate, because the way the example will use variables is too advanced at this stage, and we will immediately rewrite it in a better, more readable form anyway, the following simple command with 2 variable assignments and a single redirection is shown. Variables, in shell parlance, are parameters that have a name. And a name is a word that consists only of alphanumerics and underscores, and does not start with a number. In an assignment, the variable name, equal sign, and value must not be separated by any spaces. The command will execute a new bash instance. The first parameter is the C option. Options usually start with a dash. The second parameter is a string, enclosed in single quotes here. The string is a simple command itself that the new bash instance will execute. Echo will print the value of the variables. To obtain the value of a variable, the name of the variable must be preceded by a $sign. Finally, the greater than character redirects the output to file 1. When the command line is executed, nothing is printed to the screen. The output ended up in file 1. It's a silly example. Let's get rid of it. According to the shell grammar, variable assignments that are not followed by a command word are simple commands too. They set a variable for later use. Here we use it. And with cat we can show the content of file 2. Variables that precede a command word, on the other hand, are no longer available after the command has executed, as we can see here. But if a variable with the same name, var1, did happen to exist already with a set value, then it would have become available again right after the execution of that more complicated command line, and the last echo command would in that case have printed its value. Simple commands are the basic building blocks of the command line, and together with parameters, they are all that is needed to accomplish any task at the command line, in theory. Because for some tasks, we would have to type way too many commands in a repetitive way. Fortunately, the shell incorporates a programming language that allows us to construct bigger units out of the basic building blocks. Constructs like conditional blocks, loops, functions, etc. that can again be combined to form yet bigger units. The Bash programming constructs are the first main topic of this tutorial. The shell is also a macro expander. Before executing a command, a number of expansions are performed by the shell on the command line. This, generally, also reduces typing. So far, we have only seen one type of expansion, variable expansion. Here we have a variable assignment, and now it is expanded. What we have called the basic building blocks can thus be assembled from smaller pieces. The expansions are another main topic. Gradually, all important features of Bash will be treated, and the way how they fit together will be a key point of focus, so that we can form an understanding of the shell. We will try not to get bogged down in details from the start, but stick to some main themes at first, adding detail along the way as we delve deeper. This way, it may take longer to learn how to perform some simple, practical tasks at the command line. But the hope is that by following this route, we quickly gain a deep understanding of the shell, and that a faster road towards accomplishing more difficult tasks is paved.